happen here? Well, remember, this capital R of x, this is either going to be 0, identically 0, or its degree has to be less than the degree of your d of x, your divisor, which in this case is x minus a. So in other words, R of x is either going to be identically 0 or its degree is less than 1. Well, if its degree is less than 1, what is this degree? Its degree then can only be 0. In other words, from the division algorithm, R of x here is either 0 or degree 0. So either way, it's going to be a constant. I'm calling that constant C, okay? So what we really get then is this. But we can actually figure out what this constant C is. As you can see, what I'm doing is I'm replacing x by a, right? So f of a has to be a minus a times q of a plus c. And of course, this part goes away because you have 0. And we get c on the right side. So f of a we get is c. C is equal to f of a. And so we get this. So what we get then is this. This is why the remainder theorem is true. Okay? And we can actually go a step further with this and get, this is actually going to be called the factor theorem. Namely, if x minus a, let's say that was a factor, okay? Well, for this to be a factor, if you were to divide capital F of x by x minus a, right? Your remainder has to be 0, right? It's just like with numbers, right? With integers, excuse me, right? If you have a number that's a factor, when you divide, you have to get 0 as a remainder. So when you divide capital F of x by x minus a, you really have to have a remainder of 0. What is the remainder? It's f of a. So this forces f of a to be 0. So if we know x minus a is a factor of capital F, that implies f of a must be 0. What about the converse? That is the other direction true? Well, if f of a was 0, right? This is going to be 0. And you have capital F of x is x minus a times q of x only. So this part would be gone and we have this. So in other words, if you evaluate capital F at a and get 0, that tells you x minus a is a factor of capital F of x. And really what I just showed you here was the factor theorem. That a polynomial capital F of x has x minus a as a factor if and only if f of a is 0. If and only if means both directions. So if x minus a is a factor of capital F, then f of a is 0. And if f of a is 0, then x minus a is a factor. And that's really useful. So to find out if x minus something, a number that is a factor, amounts to doing a function evaluation. So with this example, right, x squared plus 5x plus 6, okay, well, is x plus 3, which is x minus negative 3, a factor? Again, it has to be minus. So that's why if you have plus here, you have to change it to minus. Well, if you were to evaluate f of x at x minus if you were to evaluate this, at negative 3, by direct calculation, you're going to get 0. So yeah, x minus negative 3, that is x plus 3, is a factor of this. I mean, you already know that by just using what we've learned earlier in the course. What about this, though? Well, it's the same method, actually. Again, you just do f of negative 3. You don't get 0 here, you get 30, so the answer is no. So this is not a factor of this here. Okay, so that's the factor theorem. You know, it's pretty useful. It makes it a lot easier to determine if a polynomial has a factor in the form x minus a number. Okay? So here's some other examples, okay? What we're going to do now is we're going to, do some more synthetic division. Okay? This is the kind of stuff I did with my last semester. Suppose f of x was this now, okay? So f of x is this polynomial. We want to know if x minus 3 is a factor. Well, by what we just did, by this factor theorem, right? It's enough to evaluate the polynomial at 3. Okay, again, going back to this, you have x minus a number. It has to be minus a number. And you evaluate at that number. So here we have f. So f of 3. If you evaluate it, you end up getting 0 by direct calculation. Okay, so x minus 3 is a factor of f. And how would you get the other factors? Well, what you can do is you can divide. It's just like what you did with the integers, right? If you know 2 is a factor of 106, right? Well, yeah, it is. We have tests for that. But how would you actually factor it, though? What would the other factors be? You divide, right? That's what we're doing here. It's the same idea. That's exactly what we do here. Okay. So dividing, again, this is x minus 3, so we can use synthetic division. So the 3 goes here, right? Again, if it's x minus a number, that number goes here in the first column. 1x cubed, the 1 goes here. Negative 1x squared, right? So the negative 1 goes here. We have negative 14x, right? That goes here. 24 goes in the last column, okay? Just like synthetic division, okay? That's what we've done. So the 1 comes down, okay? We have 3 times 1 is 3, right? Again, this number comes down. That's in synthetic division. You have 3 times this. You multiply, and that number goes here. So we have 3 times 1. Well, that's 3. That goes here. Okay. Then you add to get 2. Okay, that's good. So 3 times 2, what's next? So again, now next you multiply these two. You get 6, that goes here. You add, you get negative 8. Okay. Now we do 3 times negative 8. That's negative 24. 24 plus negative 24 is 0. Good. So the remainder is 0, which is what we expect, right? Because f of 3 is the remainder. But we know now what the quotient is. Remember, this is degree 3, so this is degree 2. It's x squared, or 1x squared, same thing, plus 2x minus 8. So we have all this. So this is what we have here. Okay, now, if we want to get the other factors, we would have to somehow factor this thing. Although this is a lot easier, right? It's a trinomial of degree 2, leading coefficient 1. And I actually go into factoring this, right? Remember, what do? You want 2 numbers whose product is negative 8, but the sum is 2. Well, 4 and negative 2, right? So we use those. And from here, it follows that we can factor this completely. That is, we can factor it all the way to get this. Okay? So by using polynomial long division, or well, synthetic division, I guess, we were able to factor this polynomial. Notice also that all the terms there were no missing terms here. That's why there were no zeros in the very first row. All right, so that's good. So we were able to factor this. Are there any questions about this? Oh, sorry. Next example is a little tricky. So again, bear with me on next example, but let's start it at least. So for this one, what's different about this? Well, notice that this is our f of x, right? Notice also that we're going to divide by 5x plus 3. Okay? That's what we want to divide by. Excuse me, we want to know if this is a factor. Okay? Now notice you cannot use the remainder theorem or the factor theorem, right? Mostly because it's not in the form of x minus a number, right? We can't do that. In other words, if you went back, here we go. To use the factor theorem, you have to have x minus a number. We don't have that here. But we can get around that. Basically, what I'm trying to show you here is, right, if you want to do this quotient and you want to find out the remainder, right? Now, you could do long division if you wanted to, but you could also use synthetic division. Namely, what you can do, you see how the leading coefficient here is 5 in the bottom? Well, let's factor that out. And that's what I'm doing here. I'm factoring out 5. And I'm doing that by multiplying top and bottom by a fifth. Okay? Yeah?
Do we have to do all of this if we're using long division?
No, not long division. So I think long division might be a little bit better. It's just that last semester I didn't do long division. I did only synthetic division. So
this all applies to synthetic?
If you're going to do synthetic division, you can do that. It's just that you have to do these extra steps if you do synthetic division.
Okay, thank you.
You're welcome. Sorry if I scared you. But what you can do is you could basically divide top and bottom by 5. That is, you can multiply top and bottom by 1 over 5. And what happens is this. In the top, you'll get all this. But in the bottom, you'll end up with x plus 3 over 5. Because now you have x, well, you have x plus something, right? And that's the same, and you can write that as x minus the negative. So now you'd be able to use synthetic division. But again, I think it's easier to just do polynomial long division. And we'll do that next time. So I know it's like a minute early. Again, what I was originally going to do is show you how to handle a question like this using synthetic division. But I think it's better to do polynomial long division. Again, I didn't expect to get this far. So we have like a minute left anyway. So why don't we just stop? Are there any questions though?